Is it the end of the internet? Networking Part 3. An IP address has 4 values, each between 0 and 255. 1 byte each, called an octet. We typically see this written in the decimal system, so an IP address looks like this: 128.196.068.002. You can write the octet without the leading zeros, so 128.196.68.2, just for convenience. Such an IP address allows for 2 to the 32nd possible addresses. That's 4.3 billion addresses, and that seemed like plenty at the time. The way of defining things is called IPv4. For a while we just sailed along on the IPv4 boat, but there was a problem. Increasing demand was sneaking up on us. Now IPv4 is sinking, and we're going to need a bigger boat. We need a bigger address space, that is, a bigger boat. This time we want to do it right. Thus IPv6 is born. IPv6 is 2 to the 128th addresses instead of a measly 2 to the 32 for IPv4. Will that be enough? Yes. IPv4 is 4.3 billion. Wait, IPv6 is 360 times that gigantic Undecillion number. That's an Undecillion. So as I was saying, 340 Undecillion addresses, more than the value of a solid gold Earth, more than the value of a solid platinum sun. An undecillion is more than a billion, a trillion, a quadrillion, a quintillion, a sextillion, a septillion, an octillion, a nonillion, or a decillion. It's an undecillion. So an IPv4 address is 4 octets, written usually like this. An IPv6 address is 16 octets, each written in base 16 or hexadecimal. Because it uses hex, each octet is represented by a pair of digits, but these include the letters up to F. So, as I was saying, an IPv6 address looks like this. But switching the whole world to IPv6 is a major chore. It's going to take a while. So what can we do in the meantime to ease the burden on IPv4 and avoid sinking the ship? Find out in our next 2 installments, Networking Part 4 Private Addresses and Networking Part 5 Dynamic Addresses.